Okay, so now we're going to take a look at what happens on a ring with more than two nodes. So we've got, again, a relatively simple topology, just four hosts, SSH-DIN all here, host 1, 2, 3, and 4 at 10.0.0.1, 2, 3, and 4. And now instead of doing a simple node that bootstraps the node and doesn't do anything else, this time we're going to run one that has a little daemon running in the background. So this one will create the node, or initialize the node, create the ring, and then it will also spawn a little background process that calls stabilize and fix fingers once every second. These guys are very similar. The only actual difference here is it's going to create the node at 10.0.0.2 on port 5000. It's going to then try and join the node at this IP address on the same port, and then it's going to spawn that background process to stabilize and fix fingers as well. So let's get started. We're going to start with host 1. And as we can see here, node.address. But more interestingly, node.fingertable. We can see that this is actually updating. So in the time that it took me to type the rest of that out, it got through most of our finger table, just a few entries at the back. And as expected, all of them are filling to ourself because we're currently the only actual ring in the node. Confirming, yep, every single entry in here is this. So now if we join our second node, we should see very similar behavior. Oh, first, actually, because we will not have time with that daemon. Oh, right. So in this case, actually, the predecessor does get updated because we are calling stabilize and check predecessor. Stabilize updates the predecessor, remember. Every time stabilize runs, it says, hey, who's my predecessor? Find out who their predecessor is. And if it's none, notify them about me so that they can update. So in that case, we actually do see that it updates the predecessor to itself. So when we join this guy, we can see actually relatively quickly that this guy is updated correctly, and this node's predecessor is in fact the node that just joined. Now this is to be expected because there's only two nodes. So let's see what happens when we add more nodes. All right, so we've just added a node. We've asked it to join host 1, but as it turns out, its hash is 58751. So if we think conceptually in the ring, host 1 is going to have the lowest, host 3 is going to have the highest, and host 2 is actually meant to sit between. So the hashes here actually work out relatively well to our to the order of our host IP addresses. And if we see the predecessor here, we should see that this points back to node 2. And if we fix our typo, we can see, in fact, it does point back to our middle host, our host 2 with the middle IP hash. Now, when we join, we don't necessarily have to have our nodes join the first node that joins. We can join anywhere on the ring. So to show that, we're going to actually have our fourth host join the node through host 2. Okay, now this node has actually a very low IP hash. So this one's actually, if we look at the order of them now, it's actually in order of lowest to highest. It's 4, 1, 2, 3. So the predecessor of this node should be 3, and the successor should be 1. Now the reason for this is, remember, it's a ring, which means that when we reach the largest node in the largest possible key in the address space, we should wrap right back around to get to complete the circle and to get to the next node on our ring. So if we look at our successor, we can see, in fact, we do climb right on up to 48299. And if we look at our predecessor, we can see that it does, in fact, reach right back around. It crosses 0 and goes straight back to get to host 3. And if we look at our finger table, in this case, because it's so far away, it's actually still all one node, which is to say the successor. But if we call it from a node that's a little further up, that has a few more nodes close to it in the key space. Here we can see that right up until about here, everything is this first node, is this immediate successor. But when we get a little bit further away, and remember, each of these is a power of 2 further away, we can see that we actually switch up to host 3, and then eventually we even wrap around and can see host. We can see that there are some nodes whose successor is going to be this 4th host.